So we're going to talk first about position versus time. And then we'll talk about velocity versus time, and then we will talk about acceleration versus time. And basically, we want to look at each one of these and see if we can really dig out of it and figure out what exactly that graph is trying to tell us. Okay. So let's first look at position versus time. This one right here. Okay. So this position versus time graph. What can you tell me about the object in this situation?
Further from its initial position.
Getting further from the initial position, right? It has a positive position. Normally, in a graph, this would be labeled position, but we understand it to mean the same thing as displacement. So you can have a positive position going one direction, a negative position if it's a negative displacement going in the other direction. And so from there, we've got it's getting farther and farther away as time progresses at. Okay, how do we know it's a constant or consistent velocity?
The gradient of the graph, the slope.
Okay, so for position time, the slope, or as IB likes to use the word gradient, is the velocity. Okay, and so that'll be very important, recognizing that it has a constant slope, therefore it has a constant velocity. Okay, now if it has a constant velocity, what can you tell me about the acceleration? It does have a constant, but what exactly is the acceleration if the velocity is constant? She's got lots of help back there. Zero, right? It's a zero acceleration because acceleration is defined as the change of velocity. If velocity is not changing, then the acceleration must be zero. Not that it's constant. Yes, it is, but it's constantly zero. All right, what can you tell me about this one?
Its position is the same.
Position is the same everywhere, therefore velocity is
Zero.
and acceleration is zero. Okay, good. So we can get that from this graph. How about this one right here? What do you see is happening with the position? Janelle, what can you tell me right here? What's happening at the beginning? Let's talk about the simpler things first. Tell me about the position first. What's happening to the position of this object as time passes? Going up, or this could, remember these could be talking about horizontal as well. So horizontally, this just means that we're getting farther from our point of origin. Okay, at some point, we stop, and then what starts to happen? Start to return, whether that means going back to the left, whether that means going down, right? That could mean any of those things. Okay, Paul, what can you tell me about the velocity of this object?
It's not constant.
It's not constant, right? We can tell that because of the slope or gradient. The velocity is the slope or gradient. So what else can you tell me?
The velocity hits zero when it goes the farthest.
Okay, so right there. Okay, so at its maximum height, its maximum displacement, that's where the velocity is zero. Great. What else? What can you tell me about the velocity here at this point, right? What I'm drawing here, this line is what's called a tangent. It touches the graph at one point. So therefore, this gradient right here is the slope of my curve at that point. What can you tell me about that gradient there? Anybody? It doesn't have to be Paul. I know it's big enough.
Positive velocity.
Positive. Not only is it positive, but it's very, very steep, a very, very high positive velocity. What's happening as time progresses?
Slowing down.
Slowing down. You can see that slope starts to decrease. And after we pass this zero, what happens? It continues to slow down, right? It changes its direction, right? You can't slow down from zero. Come on. All right, so then the velocity becomes negative, which means that it's now going back the opposite direction, which is what Chanel was pointing out earlier. So we can get that information from both the velocity and the position. And so it continues to decrease. So because the velocity is very highly positive, goes to zero, and then continues on to negative, what can we say about the acceleration here?
Negative acceleration.
The acceleration is negative, right? Because the velocity continues to decrease. Acceleration is the change in velocity over time. What's happening to the velocity? It's becoming more and more negative, so therefore the acceleration is negative. Okay. Now we're going to move on now to velocity versus time graph. So you're going to have to do something in your brain, twist it, click it, bang it, whatever it is. I don't know what you got to do, but you got to realize now we've got velocity on the y-axis. This is no longer position. Okay. Now these two graphs look very, very similar, but they ain't saying the same thing. Evelyn, what is this graph telling me? My velocity is increasing. That's right. I'm starting at a very low positive velocity, and as time goes, I'm going to higher and higher velocities. What does that mean about my acceleration?
It's the same.
Constant, but is it zero?
No.
No, it's not zero anymore, right? When I looked at the position graph, that was a zero acceleration because the velocity was always the same. The slope was always the same. With this, you read about last night that the slope is the acceleration. Okay? And so the slope of this is a constant slope, therefore acceleration is constant, but the slope is not zero here. So I've got some positive acceleration. All right? Do you remember how to get the position or the displacement from the velocity graph? The area. Okay? So what the area will give me is the displacement between those two time periods. Okay? Now obviously you can get an area for anything, but I could start at this time and say until that time, what is my area? And so therefore, what is the displacement during that time period, from time 1 to time 2, okay? This shows up from time to time. They'll give you a graph, and it'll have little grids on it, and you got to count the little squares and figure out what the displacement was by calculating an area, because it may be like a little curve or something. You just have to recognize, oh, the only way to get displacement is to count up the little squares, figure out what the actual area is under that curve. Okay? What's this one telling me? Leo?
Velocity is the same, and so acceleration is constant. Wait, no, acceleration is zero.
Acceleration 0, right? Because acceleration is the slope of this graph. The slope of this graph is?
Zero.
0. It's not changing. So therefore acceleration equals 0. But the velocity is?
The same.
Constant. So it has velocity. It's just not changing. So what would this say about the position of my object, Kyle? What's happening to the position as time progresses? It's going to increase its distance, right? And we can get that from the fact that I have a positive velocity, which means it's moving in the positive direction. You can also, again, get the area under there, and you recognize that you get a positive area, therefore a positive displacement. Okay? How about this one? It's a little bit weird.
Negative acceleration.
Okay? How do you get that, Martin?
Because it's like decelerating. I know you shouldn't say it, but it's
I'm
getting
glad you didn't
slower.
say that.
It's getting slower.
Okay, at the beginning it's getting slower.
Then it's accelerating in negative direction.
Yeah, all of this is accelerating, and it's all accelerating in the negative direction, isn't it? Which is why he was very careful at the beginning to say that the acceleration is negative. What were you saying, Leo?
The slope is negative.
Slope is negative, right? The slope is the acceleration. The slope is negative. Therefore, it has negative acceleration. Okay? However, I do have a positive velocity here. What does that mean? So it's moving forward,
Just at a slower.
but as Martin pointed out, it is slowing down. What happens here?
You start going back.
The velocity is 0, and then it starts going back. Can you give me an example of something that would give me a graph like this? This, what were you saying? A car?
Like
Goes down and comes back?
No, you go and then you put a reversing.
Okay, so I'm driving this way, I slow down, I'm hitting the brakes, and I realize that's not enough. Now I gotta go back in reverse and speed up in that direction. Okay, we can create that situation, right? Okay, but more commonly, just your ball going up and down in the air, right? You throw it up in the air, when you let go of it, it's going pretty fast. It's got a high velocity. What happens as time progresses.
Velocity decreases.
It slows down, it hits 0 at its maximum, and then it starts to fall down. All right? Cool. Just leave it there on the circle table. Thanks, Joshua. All right, acceleration versus time. What's happening here?
Acceleration is increasing.
Acceleration is increasing. What does that mean about the velocity?
Increasing at exponential rate.
Increasing, but not increasing at the same rate. It's increasing in more and more and more. Okay? On this one, what is the area?
Velocity?
It's the change in velocity. Ooh. Good. So you made the link. You said, well, this one is the area of that, and because this is the slope of that, maybe there's some connection here. If this is the slope of that, maybe the area is that. And yes, that's correct. The area is the change in the velocity. Very good. Okay? What is this?
Acceleration is constant.
Positive constant acceleration. What does that mean about my speed?
Increasing.
Increasing, right? Acceleration is zero. So that means it's not moving.
Velocity is at the same.
Velocity is constant, right? So acceleration equals 0 means that v is constant. Whatever it was, it will continue to do that. Okay, that's Newton's first law, is that if nothing else is causing a change, it will keep doing whatever it's doing. Okay, so that's the interpretation of those.